Okay. So, we are 14 lang dito sa ating Google Meet. So, let's start. So, our topic today, week 7, is IP addressing. So, double check ko lang. Wait po. Record. Okay. IP addressing. So, first is, what is an IP address? Please read Alvarez.
What is an IP address? An IP address is a 32-bit sequence of 1S and 0S, a way to identify machines on a network, a unique identifier, and a numerical label.
Okay, so an IP address daw is meron siyang 32 bits ng ones and zeros. Kasi ang bits po, or bit ay composed of 1 and 0. So what is the meaning of 1? Kawili. Ano ba yung anong meaning ng 1 tsaka ng 0? Kawili, alam mo ba? Ano ibig sabihin ng 1 or ng 0?
Hindi po.
Okay. Anyone, pwede po mag-raise ng hand. Ano ibig sabihin pag 1 at 0? Alam ko tinuro to sa grade 9 about sa bits or bytes. Okay. Sa electricity rin is ginagamit rin to. Kung mapapansin ninyo sa mga switch ninyo, meron niyang 1 at 0. Okay? And sa, tawag dito, yun. And sa mga extension, may mga 1 and 0. Yung 1 meaning is on, and 0 meaning off. Okay, sorry kasi may mga pumapasok. Okay. So, ang IP address is a unique way to identify the machine on a network. So, para siyang sa bahay din na isa siyang address kung saan isi-send or saan nanggaling yung mga file. So, saan ba nanggagaling ang IP address? Ang IP address is nakukuha nyo yan sa mga internet provider ninyo. Kasi syempre, gagana lang naman ng IP address pag meron kayong internet. So, it's a unique identifier and a numerical label. So, mamaya, ano natin, kung numerical label pa rin ba ang mga IP address. So, sorry, balikan ko lang bakit 32-bit sequence kasi sa isang buong IP address is composed siya ng 32 bits. So, pag binilang ninyo to, itong numbers or bytes na to is 32 siya. Okay? So, IP usage, used to connect to another computer. Okay, used to connect to another computer through internet. Okay. And also, pwede rin naman pag basta meron kayong router or related sa network, pwede kayong magkaroon ng IP address. Allows transfer files and email. So, what is an internet protocol? So, meron tayong video dito. Mas maganda, panoorin natin yung video. So, Internet Protocol by Spencer Bricker-Hoff III.
We've all sat down and sent out an email message before, but have you ever thought about how the message gets from one place to another? This is Internet Protocol Explained. Our language is very different from the language that a computer uses, so the messages that we create need to be translated from an alphabetic text into an electronic signal before they can be sent. This translation is handled in the computer by the separate modules in the communication protocol. Because these protocols, or rules of conduct, usually communicate with two or more modules, they are best described as layers in a stack of protocols. These layers are the application layer, transport layer, internet layer, the link layer, and physical layer. The messages that we send are filtered through these layers and broken down into small chunks of data called packets. We start with the application layer to create our message. One example of a protocol from the application layer that you may be familiar with is the Hypertext Transfer Protocol, or HTTP. The transport layer uses the Transmission Control Protocol, or TCP, to encapsulate the data blocks from the application layer. It then moves to the internet layer, where the Internet Protocol, or IP, is used to deliver the packets. These packets are delivered through the link layer, which is an Ethernet cable, to the physical layer, which is the basic hardware of your computer network. The computer that receives these data packets moves them through the protocol stack in a reverse order so that the message can be reconstructed and understood. This has been Internet Protocol Explained. Through the link hardware of your...
Okay. Chua, please explain yung itong slide, itong part ng video na to. Please summarize.
Ma'am, yung application where daw po is nagaan sa HTTP ko, hypertext,
Hypertext Type Protocol.
ayun po. Sa transport where daw po is transmission control protocol. Tapos po sa internet where po is IP or internet protocol po. Sa link where po is Ethernet. Yung sa physical po is yung hardware po kung ano po yung ginagamit po.
Okay. So, mapapansin ninyo, meron siyang 5 layers para makapunta sa PC, 4 layers para makapunta do sa pinaka-hardware. Okay? So, ganyan yung flow ng internet protocol. Okay? Ganyan flow nung paano nagsisend yung isang files papunta sa physical hardware ninyo. Okay, next tayo. Wait lang, sorry. Okay. So, meron tayong part of IP address. Meron siyang 2 parts, network part and local or host part. So, IP structure consists of 4 sections. Each section is 8 bits long. Each section can range from 0 to 255. Written, for example, of 128.35.0.72. So, sinasabi dyan, yung meron tayong 2 parts ng IP address. So, for example, this first part is the network and yung yung second, third, and fourth na section is the host. Okay? So, each section daw is pwedeng mag-range siya ng 0 to 255. So, pinaka-highest niya na is 255. Then, yung each section daw niya is 8 bits long. So, mamaya papakita, meron doon sa Ipv4 versus Ipv6 kung paano mag-compute or mag-convert nito ng true bits or bytes. Then, ayun, sinabi naman it has 4 sections. 1, 2, 3, and 4. So, meron tayong 5 classes of IP address. Yung class A is reserved for governments. Class B is reserved for medium companies. Class C is reserved for small companies. Class D are reserved for multicasting, and Class E are reserved for future use. So, mapapansin ninyo, mamaya na most of the time is lahat tayo is gumagamit ng Class C. So, ito yung pinaka ginagamit natin sa mga bahay natin, sa mga offices, is the Class C. So, ano ba yung range ng IP ranges? So, yung IP range ng Class A, so mula siya sa 1, ito yung network niya. Then, hanggang 1 to 6. Okay, 1 to 126 is pwedeng maging network. Then, ito naman, yung second, third, and fourth is pwede siyang maging host. So, pwede siyang mag-support ng 16 million na hosts. So, different numbers, different combination of numbers is pwedeng makabuo ng 16 million na hosts. Okay? Next naman is the Class B. Sa Class B, so hindi niya na pwedeng magamit yung 1 to 126. So, start na siya kay 128 to 191. Okay? So, supports niya is 65,000 hosts on each 16,000 networks. So, hanggang 16,000 networks ang kaya niyang i-produce. Then, dito tayo sa Class C. So, ito tayo is yung first 3 na part is the network, and ito lang ang pwede nating gawing host. Okay? So, 1 hanggang 254 na host. So, 1920.1 hanggang 223, 255, and 254. So, pwede kang mag-support ng 254 hosts on each 2 million networks. Okay? So, sa Class D naman is reserved for multicast group. Then, Class E is for research. So, ito yung sinasabi ko sa inyo kanina, na the first part is the network. Then, yung lahat po is pwedeng mag-host. So, ang network kasi, yan yung number na hindi pwedeng magbago. Okay? So, kung nakalagay dyan is 126, for example, sa isang company, ang network niya is nag-start sa 126. Okay? Then, itong host, pwede niyang bagu-baguhin. Depende sa ilan yung computers na nakakonekta sa network. So, 126.0.0.1, 126.0.0.2. So, makakabuo siya ng maraming network. Dito naman sa Class B, ito yung dalawang network. Okay? Then, meron siyang host na meron siyang dalawang host. Then, di sa Class C is 3 network, then isang 8 bits na host. Or yung last part is yung host. Okay, so ulitin ko, yung network, for example, sa bahay ninyo, yung first 3 numbers, kunyari 192.168.1, then ito yung magbabago. So, 1. So, 192.168.1. So, may another computer ka na naman. So, lalagay mo dyan is 2. Isi-set mo doon sa another computer na 2. Okay, so yun yung purpose niya. Okay, so let's discuss the IP address through this video.
Computer, and this is you watching what is an IP address. IP addresses represent where you live on the internet and are needed to send messages to computers outside of your own network. Imagine when you send a letter to your great aunt Mew. You put her address on the front of the envelope and the return address on the back. You send the message and expect to get a reply. This is what is going on with your computer right now as you're watching this, except the destination address of the thousands of messages you're sending every minute is some YouTube server, and the return or source address is the computer in front of you. Just like with house addresses, you won't find 2 computers connected to the internet with the same address. Somewhat differently though, Computers don't use geographical addresses, but rather use a string of numbers called an IP address. These IP addresses are how the devices involved in passing the message know who is sending what to whom. Not including a source IP when sending a message over the internet would be like sending a letter with no return address to a complete stranger who has to deal with billions of letters every minute and expect to get a reply. Yeah, good luck with that. So, quick recap. IP addresses are a unique series of numbers which identify computers on the internet. Want to watch YouTube? You need an IP address. Want to send an email? You need an IP address. Want to browse GIFs of adorable cats? You need an IP address. Cool. Moving swiftly on. If you look at an IP address in a bit more detail, you'll notice that it's basically 4 numbers separated by dots. This particular IP address would be pronounced 192.168.1.1. Using dot or point between the numbers doesn't really matter, it's just personal preference. As mentioned in a previous video, sending information across the network will eventually lead to ones and zeros being transmitted in the form of electrical signals. An IP address has 32 of these ones and zeros. With a little bit of arithmetic, we can work out that there are 4,294,967,296 addresses available for use on the internet. Wait, hang on. There are 7 billion...
Okay. Okay, Daniel, please summarize yung video about IP address. Naririnig ba ako, Daniel? Okay, next, David Carl. Anyone po, para ano ang IP address, sa-summarize yung napanood na video. Pwede mag-raise ng hand. Or mag-open na lang ng mic. Okay, Gravador.
Ma'am, yung nakakuha ko po sa video is yung IP address po consists of 4 separate numbers po na yung po yung kinakailangan para makapag-send po ng files through other devices from other networks po. Halimbawa, yun nga po yung example sa video na magsisend ka po ng email sa tita mo na halimbawa po nasa ibang bansa tapos ikaw nasa Pilipinas ka po. Kailangan mo po ng IP address para maipadala po yung gusto mo pong mai-send na letter sa akin.
Okay. Next, Janela. Ilan ang class ng IP address? Janela? Parang nandito.
5 po. 5.
Okay. Anong class yun? Janela? Ano yung class na yun? Jervin. Jervin? Wala kang mic. Yes, Kit.
Yes po.
Ano yung mga classes na yun?
Ng
IP address.
po.
Yes.
Mga classes po.
Yes.
Class A po for large networks po.
Okay.
Class B para medium-sized networks, parang universities lang po. Yung Class A po para large companies po.
Okay.
Class C po used for small networks, para sa ISPs lang for customer subscriptions.
Okay.
Class D para multicasting po. At Class E used for experimental testing.
Okay. So let's go to the next topic. Thank you. Next is the difference between IPv4 and IPv6. So makikita niyo yan kung nagsiset up kayo ng IP address sa computer ninyo is meron tayong IPv4 and IPv6.
An IP address is a numeric address. It's an identifier for a computer or device on a network. Every device has to have an IP address for communication purposes. The IP address consists of two parts. The first part is the network address, and the second part is the host address. There are also two types of IP addresses. The first one is the most common one. It's called IP version 4. And a second type is IP version 6. IP version 4 is the current version of IP addresses. It's a 32-bit numeric address written as 4 numbers separated by periods. Each group of numbers that are separated by periods is called an octet. The number range in each octet is 0 to 255. This address version can produce over 4 billion unique addresses. In the world of computers and networks, this IP address in this format here is meaningless. Computers and networks don't read IP addresses in this standard numeric format, and that's because they only understand numbers in a binary format. A binary format is a number that only uses ones and zeros. The binary number for this IP address is this number shown here. This binary number is what computers and networking devices actually read. So the question is, how do we get this binary number from this IP address? IP address 4 is made up of 4 sets of 8 binary bits. And these sets are called octets.
Okay, so kaya siya ginawa na sinasabi na each part ng IP address is octet kasi 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay? Na binary.
The bits in each octet are represented by a number. So starting from the left, the first bit has a value of 128. Then 64, then 32, and so on, all the way down to 1. Each bit on the octet can be either a 1 or a 0. If the number is a 1, then the number that it represents counts. If the number is a 0, then the number that it represents does not count. So by manipulating the 1s and the 0s in the octet, you can come up with a range from 0 to 255. So for example, the first octet in this IP address is 66. So how do we get a binary number out of 66? First, you look at the octet chart, and you would put 1s under the numbers that would add up to the total of 66. So you would put a 1 in the 64 slot. So now you already have 64, so we need 2 more. So let's put a number 1 in the 2 slot. So now if we count all the numbers that we have 1s underneath them, you would get a total of 66. All of the other bits would be zeros because we don't need to count them since we already have our number. So this number here is the binary bit version of 66. So we'll put that number down here.
Okay. Manawag? May mic ka ba? Okay, Navo. Please explain paano naging 01000010. Yung 6.
Yung sa 6,
Paano naging ganun yung computation or pagko-convert?
so bali po kung for example po, 66 yung first number po sa IP address, lalagyan po ng 0 yung mga numbers sa octet chart na hindi po kailangan to add up para mag-equal dun sa first number. Like, for example po, yung 64 and 2 lang po yung may number 1 kasi yun lang po yung numbers na kapag in-add, magre-result sa 66. Then yung other numbers po na hindi na kailangan para i-add up, yun po yung lalagyan ng 0.
Okay. Palikpik. Please convert 94 nga sa octet.
94 po, ma'am.
Sa exam ninyo may ganyan na. Co-convert kayo ng IP.
$96 po ulit ba, ma'am?
Ha?
Ano pong number?
Yung 94, yung second na
90. Ano po? Ano po, ma'am? 01. 01. Ay, ulit po, ma'am. 01. 011110 po.
Okay. So, 01011110. Okay. So, yung ganong part is, paano yung computation mo, palikpik?
Inad ko po yung 64, 16, 8, 4, 2. Kaya po sila yung naka-turn on, yung 1 po. Tapos yung the rest po is 0 na kasi turn off po.
Okay. So, lahat ng gagamitin yung numbers mo, mag-start kayo sa pinaka-mataas. Okay? So, for example, sa 94. So, hindi siya pwede natin gamitin yung 128 kasi nga mas mataas si 128 kaysa kay 94. So, next number na pwede natin gamitin is the 64. Okay? Then, after ng 64, pwede kayong, ang ginawa kasi ni Palikpik is inad niya, okay, yung pwede niyang gamitin. Pwede rin naman, isa-subtract ninyo, then titingnan ninyo kung ano yung natitirang number na pwede pwedeng ibawas dun sa number na sinubtract ninyo. So, ganun yung pwedeng mga technique para gumamit kayo ng octet chart. So, tandaan ninyo yan kasi kasama yan sa exam. Yung exam natin is gagawin ko ngayong week, then pwede nyo matapos yun hanggang next week. Okay? So, next tayo.
So let's do the next number, which is 94.
Ayan.
So let's put a 1 under 64, 16, 8, 4, and 2. So if we were to add all the numbers that we have ones underneath them, we would get a total of 94. And since we don't want to count any of the other numbers, we just put zeros under the rest. There's 4.
Okay. So, next na tayo.
When the internet was first developed, programmers didn't realize how big it would become. They thought that IPv4, which produced over 4 billion addresses, would be enough. But they were wrong. IPv6 is the next generation of IP addresses. The main difference between IPv4 and IPv6 is the length of the address. The IPv4 address is a 32-bit numeric address, whereas IPv6 is a 128-bit hexadecimal address. Hexadecimal uses both numbers and alphabets in the address. So with this type of address, IPv6 can produce an unbelievable 340 undecillion IP addresses. That's the number 340 with 36 digits after it. So as you might have guessed, IP version 6 is more than enough for the foreseeable future. So as stated before, IP version 6 is a 128-bit hexadecimal address. It's made up of 8 sets of 16 bits, with the 8 sets separated by colons, as you can see here. So in a similar way that we converted an IP version 4 address to a binary number, this is how we convert a binary number to a hexadecimal address. In an IP version 6 IP address, each hexadecimal character represents 4 bits. So we have to convert 4 bits at a time to get one hexadecimal character. So starting from the beginning, we convert the first 4 bits and put those bits up there against our 4-bit chart, which includes an 8, 4, 2, and a 1. So if we count the numbers that we have ones underneath them, you wind up with a 2. So a 2 is the first hexadecimal character in this IP version 6 address. So let's do the next 4 bits and put those under our 4-bit chart. So if we count all the numbers that we have ones underneath them, we have a 4 and a 2. And if we add those up, we get 6. So a 6 is the second hexadecimal character in this IP address. So let's do our next set of 4 bits. And if we add all the numbers that we have ones underneath them, we get a total of 13. But the problem is, since 13 is a double-digit number, we cannot use a double-digit number to represent 4 bits. And that's because in a hexadecimal format, double-digit numbers have to be represented with a single alphabet, which is A through F. So in this case, we have to use another chart for any 4 bits that the sum is 10 or higher. So in this chart up here, if the sum was 10, then we would use the letter A. Or if the sum was 11, then we would use a B. But in this case, our sum is 13. So now for the third character in our binary number, we would put a D. So in our last example, let's do the 4th set of bits. And if we add those up, we get 11. So we have a double-digit character again, which means that we have to convert it to a single character alphabet. So if we look at our chart up here, 11 converts to a B. So the first 16 bits of this binary IP version 6 address converts to the hexadecimal address as 26DB.
Okay. So, hindi ko na kayo papakonvert ng hexadecimal. So, let's summarize lang ano yung difference ng IPv4 at ng IPv6. Reyes, give me one difference ng IPv4 and IPv6.
Yung one difference po nila is yung length of address. Yung IPv4 po ay 32 bits and yung IPv6 naman po is 128 bits.
Okay, next, the Banaw. Another difference nila. Vargas.
Another difference po nung dalawa is yung number of IP addresses na kaya po nung i-provide. Yung IPv4 po up to 4 billion po kung di po ako nagkakamali. Tapos yung IPv6 hanggang 39 digits po yata.
And this
Kaya.
Okay. So, kaya siya nagkaroon tayo ng IPv6 kasi nga sa sobrang dami so nakikita na nila na yung 4 billion is hindi nakakayanin kaya sila nag-produce ng IPv6. So, meron tayong differences din. So, number 2 is dot and semicolon. So, IPv4 is gumagamit sila ng dot para mag-differentiate ng every part ng IP address. Then, sa IPv6 naman mapapansin ninyo is semicolon ang ginagamit niya. Next is hexadecimal ang ginagamit ng IPv6 which is combination siya ng letters and numbers. So, yan. So, 10 is equal to A, 11 is equal to B, 12 is equal to C, 13 is equal to D, 14 is equal to E, and 15 is equal to F. Then ito is another is again is 128 bits. So itong binary na to is composed of 128 bits. So every part is sinahati sa 4. Okay? Para mag-convert ng 4-bit chart. Kung kanina ang ginagamit natin is 8-bit chart, dito is 4-bit chart. So, yun lang po ang differences nila. Next topic tayo, any question pala? Sorry. Wala? Okay, next topic tayo. Contingency plan. Stop recording lang ako.